So when you burn any type of fuel, a combustion reaction is going to occur, which releases CO2 and water vapor. CO2, carbon dioxide, is a greenhouse gas. That can obviously have some strong impacts on our climate. The more fuel we're burning, the more CO2 we're producing in the atmosphere. So the purpose of this lab is going to be to determine the energy content of 3 different types of fuels by burning a certain amount of that fuel and capturing the heat released in a known amount of water. So we're going to be heating up water, and we're going to be able to capture the amount of heat that was released from the fuel into that water over a certain amount of time. As far as initial materials are concerned, for this lab we're going to need an iPad, LabQuest, temperature probe, 250 milliliter beaker, metal tin, and a stir rod. And we're going to need a double ring stand setup. So you're going to want one ring stand with the actual ring. That's going to be on the bottom, and you'll set one up with just a clamp above it. That'll make more sense in just a second here when we set up the experiment. But you'll want to get this set up, and you'll want to get your initial materials right away. So here are the 3 fuels that we're going to be using for this lab. Got ethyl alcohol, a candle, and lamp oil. So we're going to be running a trial for each of these 3 types of fuels. For the purpose of this lab, I'm going to start with the ethyl alcohol. So the first thing that we need to do for this lab here is measure the weight of our empty can. So I've got an empty can right here. I've already inserted my stir rod. You're going to want to make sure that you measure it with the stir rod in each time for consistency. Leave the Petri dish on here. Don't take this off at all. Leave this on here. Once it's settled, once the weight settles, I'm going to zero it out. It's to keep the surface of this clean when we build soot on our can as we start to burn some fuel on the bottom of the can. I'll weigh the can. And I'm going to record this in my lab write-up. Once you have your initial can weight, you're going to grab 200 milliliters of water, 200 milliliters of water, and we're just going to dump it into our can. And then we're going to take our can and we're going to go weigh it again. So the very next thing that we're going to do is measure our ethyl alcohol burner. So I've got an ethyl alcohol burner right here. It's got several parts to it. I would measure for both the before and after. I would measure with everything on it. So I'm going to take a measurement of this right now. Before we do anything here, because we are using fire, we're going to grab a pair of safety goggles. Everyone in your group should be wearing safety goggles when we're burning things. Mr. Wells already has his on. All right, so this is how this trial is going to work. I've got my LabQuest hooked up to my temperature probe here. I'm just going to insert the temperature probe into the clamp. I have my tin can that has water in it now. I'm going to rest that up on the ring stand here. Then what I want to do to get my initial temperature is to lower the temperature probe into the metal can. Show you this really quick. So you want to make sure that the temperature probe is in the water but not touching the bottom. You do not want the temperature probe to be touching the bottom. Reading out an initial temperature, and you're going to record that in your lab data sheet. Okie dokie, I got my alcohol burner right under the tin can. Next thing I'm going to do is grab a lighter, and I'm going to light it. Carefully light it. I would recommend using the flame shield, so once you've got it lit, using the flame shield can prevent interference from people walking around, from wind, stuff like that. So you should have a nice steady flame going. I'm probably going to have to adjust my tin can here. So essentially what we're going to be doing here is keeping an eye on our temperature probe. We're just concerned about the live reading, so we're not going to set up anything. We're just concerned about our live temperature. So we're not actually collecting any LabQuest data in this. We're just using it to measure temperature. So what we want to do is wait till the temperature reaches 45 degrees or 10 minutes, whatever comes first. So either wait 10 minutes or stop when the temperature reaches 45 degrees. So we'll come back in about 10 minutes. So it looks like my temperature has already gone above 45 degrees. Awesome. So what I'm going to want to do now, move the burner out of the way here. And I'm just going to quickly stop the flame here. We can get a final temperature of our water. So one thing to make sure is I want to just mix this around just a little bit here. It'll give us a more accurate final reading for our temperature. So I'll record final temperature in my lab sheet. And then we're going to have to weigh a couple things. We're going to have to weigh the final the final weight of the water and the final weight of our alcohol burner. One thing I'm going to do quick here, you'll want to give yours time to cool down a little bit. I want to make sure that I put the rubber stopper back in. It'll help alcohol from leaking out. And also, since I weighed the rubber stopper the first time, I have to weigh it again for my final weight. Okay, the scale is zeroed out here. I'm going to weigh the final mass of my ethyl alcohol burner. Make sure that everything is back on here again. When you're all done with all of the trials, dump out my last thing of water. Got some soot buildup on my can. What I'd really ask every group to do would be to clean off the bottom of your can. Clean it off, rinse it off with a paper towel. Before we move on to the candle and the lamp oil trials here, I'll take a second to fill out the whole data table here for the ethyl alcohol. I'm not going to do this for the other two, but I want everyone to see kind of the general idea of how to fill these out as you're going along. So everything here in pink is something that I have to calculate. So mass of fuel burned. Mass of fuel burned is going to be your initial fuel minus your final mass of fuel. And so for me, that'd be 186.5 minus 184.4. So that should be 2.1. For the mass of water heated, I'm going to take my mass of can plus water minus the mass of my empty can. So for me, that looks like it's 196.1. For the change in water temperature, that's going to be my final temperature minus my initial temperature, so 47.2 minus 23.4. For me, that's 23.8. For my energy and calories, so these last two in gray are a little bit harder. I'm going to multiply the mass of water heated, which is my 196.1. And I would prefer you show work for this part, 196.1, and I'm going to multiply that by my change in water temperature, so 23.8. This is in grams, this is in degrees Celsius, and so my final calculation for this is going to be 4,667.18 calories. For calories per gram of fuel burned, I'm going to divide the calories I just calculated, so 4,667.18. Calories. And I'm going to divide that whole thing by the mass of fuel burn. So in my case, that was 2.1 grams. And so for me, that's going to equal 2,222.47 calories per gram. Now I spilled a little over into this other section here. You can clean that up. I want you to show your work, but you can clean that up, put it at the bottom down here. So that was mine. Those were my numbers. Obviously yours are going to be different. They could be even quite a bit different. But that's the general idea of how you calculate these last two equations here. So trial 2 is going to be our candle trial. The procedure for both trial 2 and 3 are going to be very similar to what we did with the ethyl alcohol. So for the candle here, you're going to record the mass of the empty can, fill your can with, so this is important, you're only going to use 100 milliliters of cold tap water instead of 200. This is just for the candle one. You're going to use 100 milliliters. Record your initial mass, record initial temperature, record the initial mass of the candle, and then you're going to run the experiment just like the first one. So you're going to stop when the temperature hits 45 degrees or after 10 minutes. I'm going to give you a hint. For most of you, it's going to be about 10 minutes. So keep an eye to see if it hits 45 degrees, but very likely it's just going to be 10 minutes. You're probably going to have to lower your ring stand because you want it to heat up better. So make sure you adjust your whole ring stand setup with the temperature probe in it. So it's a little lower for the candle here. I put a little basin here. You could ask me for one of these for the candle trial. Just make sure that if you spill any wax, you don't have to use this, but if you spill any wax, please clean it up. For the lamp oil trial, remember here, again, it's going to be 200 milliliters again of cold tap water, just like the ethyl alcohol. And same idea, you're going to run the experiment, taking all of your initial measurements, you're going to run it. This one should heat up really fast. Look at that flame. This should heat up pretty fast, so probably you're going to just want to be aware that it's going to hit that 45 degrees pretty quick. I don't think you'll have to wait 10 minutes for this one. This gets hot really fast, and you're very likely going to want to raise your ring stand. So I raised my ring stand quite a bit here. Otherwise, the can is going to get really messy. It's going to be extra time to clean up and scrub off the soot that builds up on the can if you have it super close to the source of the flame. For this final table where you're comparing and contrasting your three different types of fuels, don't tell me stuff that I can find by just looking at your raw numbers. That would be more quantitative. I'm looking for some qualities or qualitative comparisons between the candle alcohol and the oil. So things like efficiency and odor are good examples of qualities of fuel that you'd have to consider when using a fuel source that you won't necessarily get just straight from the data that you had on the first page. One last thing here, these cans. Again, take some time to clean off the bottom of this can here at the end. I have some sponges or paper towels up in the front. Take some time to scrub off the soot. If you leave a big mess, sooty mess on the can here, let me pull up a picture. So that's a student that I had who actually grabbed a can that somebody left dirty and they didn't see it because somebody put a dirty can back in my can rack. So again, please clean off the bottom of your can because you don't want to be the person that made somebody else get a bunch of gross soot and stuff on their hand. Let me know if you have any questions with the rest of this lab write-up. This was our fossil fuel lab. Thanks for watching.